A small sightseeing plane takes off from a landing strip and flies 70 kilometers at 80 degrees south of west. Okay, so let's do that much. So we need 80 degrees south of west. So that means we got to start with a line that's west and then swing to the south by 80 degrees. So there's our 80 degrees south of west. And this flies 70 kilometers. So let's go ahead and put that as a 70. And then it changes course and flies 75 kilometers at 40 degrees west of north. Okay, so we have to make a north, and then we got to swing around to the west by 40 degrees. So this is 40, and this travels for 75 kilometers. So there's 75. And then if the plane wants to head straight back to the landing strip, find the distance and direction it should fly. So then we've got to head back here to the landing strip, and we want to know that distance, and we've also got to get a direction. So let's look at this and see what we can figure out from what we have and what we need. We've got two sides. I don't know why I put a degree on there. We've got two sides, and we have part of an angle here, but we don't have the rest of the angle here. But let's see if we could figure out how we could get at that. We have this west measurement, so I could put on a parallel line here, and here is our transversal. So if that side is 80, this side is also 80. And how that helps me is because the north and then this other line here are at a 90, so that leaves 10 degrees for this angle. So now I know the angle inside the triangle is going to be 50 degrees. And that will be enough information to be able to find x, because I have side, angle, side. So law of cosines is going to work. And so I'm going to have x squared is going to equal the sum of the squares of the other two sides, 75 squared plus 70 squared, minus 2 times their product, 75 times 70, times the cosine of the angle between those two vectors, which is 50 degrees. So I can put that in the calculator and get that totaled, and then take the square root of that. And I'm going to go to 2 decimal places. It looks like that's 61.45 kilometers. So that is our distance to get back to the landing strip. Now we need to look to see how we can get the angle that this is going to head. So let's go ahead and figure out this angle in the triangle, and then that can help us to figure out what we need for the direction angle. So I have an angle and a side opposite at pair. So sine of theta over the side opposite at 70 equals the sine of this angle we have here, which is 50 degrees, over the side we just found, 61.45. So we could multiply the 70 over there, and then theta is going to be the inverse sine of this quantity here. So let's put that in the calculator. And that looks like that's 60.8 degrees. So this whole angle is 60.8 degrees. But if we wanted to measure the direction we're heading back here, we could measure that off from east, and we'd need to know this little piece in here. So let's see if we can figure out how we would get that. Let's make a north-south line. Here is a parallel line to this line, so alternate interiors. This is 40 degrees, and the whole thing here is 60.8. I can see then that's looking at these red lines, this is a 90, so this little piece of the 60.8 is got to be 50 degrees, because this 40 plus this has to add up to this right angle. And so that leaves, for my little angle in here, that leaves me 60.8 minus 50, which is 10.8 degrees. So the direction we'd need to head would be 10.8 degrees north of east.